Hello everyone, welcome to our class. Today we want to talk about how to represent negative numbers in binary. So in decimal numbers, we just use negative, the symbol to represent the decimal number, right? But in a binary, in our computer world, there's no negatively symbol. Everything is 0 and 1. So how we use 0 and 1 to represent the negative numbers? This is a very interesting topic to talk in this class. So the first idea, for negative numbers, for example, we have 81 is positive number, then we want to represent the negative number, for example, negative 81. How can we do? We don't have any symbol, we just have 0, 1. The first idea is maybe we can use the first digit to represent the negative or positive. If 0 is positive, if it's 1 is negative, then everything else will be the same, right? So in this case, this can represent kind of negative 81 because this is in binary, this is 81, right? So this is the first idea. This is not bad actually. We can use the digit to represent this, but this is not a really fantastic one. Why? First of all, when you do a computation, if you want to do 81 plus negative 81, what you will get? you the computation is not so easy, right? You have to like think about, okay, I need to compare the first digit, then I try to use the first digit to do something, and if it's a negative and it's a positive, then I need to do the subtraction. Otherwise, I just do the addition. Does not make too much sense when we do a computation. We want to get the two number, we just do the addition. We don't want to compare each like a particular digit to see if we want to do a subtraction or addition, right? So this is not bad, but this is not fantastic. And also, there's another problem is that if we want to represent zero, zero is a positive number or negative number. We don't know. Positive or negative. Okay, so how about we use both to represent zero? Okay, we can do that. But in this case, we lose one number. So for 8-digit number, we can represent 256 different numbers, right? But in this case, we can only represent 257 numbers because there's a two binary numbers represent in one same decimal numbers. So this is another problem. So first idea is okay, but not fantastic. Let's look at the second idea. The second idea is called one's complement. The one's complement is a good idea. First of all, you can easily do a subtraction or addition. So what's the first, how to implement this first idea? So if we have a negative 81, the idea of this negative 1 is we just reverse everything. So if we want to do the negative 81, we just reverse 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 0 to 1, 0 to 1, and 1 to 0. So this is actually the negative 81. So if we want to do the 81 plus negative 81, what we will get is 1, 1, 1, 1, 1, 1, 1. Everything is 1. So we can easily understand, okay, if we try to do this, the everything is 1, then we can say they are the same. So they are 0. So it's much easier to compare the first digit because you can compare all of this stuff by this. You can maybe just plus 1 and make it like 0, right? So this is a good idea. This is definitely a better idea, but it's still not good. First of all, we still need to compare this 1, 1, 1, 1. So we want to, if 81 plus negative 81, they should got 0. But we got this kind of like big number. So this is not fantastic too, because we cannot do it like in one step. We need second step to compare the all one, and all one is not easy, not hard to compare compared to the previous one, because previous one you cannot guarantee what's the format. It can be a really weird format when you do addition, right? So it's good, but it's not fantastic too. And also, still another problem is that you will still have two number to represent the same one. For example, you have a 0 which is 0, 0, 0, 0, 0, 0, 0. And still, if you have a negative 0, it's be 1, 1, 1, 1, 1, 1, 1, 1. So everything for 1 represents 0. Every 0 represents 0. So you still have two number they are the same. Okay, so this is definitely a better one, but this is not fantastic. So actually, we have another idea to make it happen. It's called two's complement. Two's complement. The first idea is the same as the one's complement. We reverse the digit. However, after we reverse the digit, we plus 1 here. So actually, at the end, it will be 1, 0, 1, 1, 1, 1. This is a key for two's complement. So why we need two's complement? Let's try addition. This 1 addition is 1. What will happen? It will be equal to 0, 0, 0, 0, 0, 0, 0, 0. And of course, there's a 1 extra digit. But because the memory is limited, we will definitely ignore this 1. We don't have enough space to store this nice digit. We only have 1 byte, 8-bit. We only have 8. So we got 0. We just try to do an overflow and try to ignore it. In this case, we can easily do it in a 0, 1. And you can see 0, 0, 0, 0, 0 is different to the negative 1 or positive 1. If we try to do a number like 0, 0 equal to uh, 0, 0, 0, 0, 0, 0, 0, 0, and negative 0 still will be 1, 1, 1, 1, 1, 1, 1, 1, plus 1. So still got all 0. So actually, you only use one number to represent 0. There's no possible 0 and negative 0 in this case. So you can use all 25, 256 like a combination, like different combination to represent 256 numbers. You don't lose any numbers. Okay, so this is two's complement. So there's a three-way, and we usually use two's complement to implement these negative numbers in binary. So if you look at the range of two's complement, if it's onside means it's always positive. It's a positive number. If it's positive number, you can represent 0 to 0 to 255, 256 numbers, right? But if you want to use side one, you want to represent negative because the first digit will be used to like check it's a negative number or not or positive number. So you can only get the range negative 128 to 127. So still 256 numbers, but the range will be different. Depends on the negative number or positive number. Um, if you want to use a side one, because you need to consider the negative number, so you lose 1 bit. If you lose 1 bit, you can represent what you can represent. The range will be different, definitely. Okay, so think about it. It's not so hard to understand. So usually we use two's complements to implement our binary stuff. Okay, so let's talk about overflow and underflow in this case. What's an overflow? Imagine that you have one number, it's called 127. 127 in binary, if it's a side number, is if you have a positive negative, of course, the first one is 0 because it's a positive number, but everything else is 1. And you try to plus 1 here. What happened? It will give you 1, 0, 0, 0, 0, 0, 0, 0. What's this number means? It's actually a negative number, right? So you do 127 plus 1, but you got the negative number. This is insane. This is not reasonable. So in this case, we call this overflow. When you try to do a computation, you also need to worry about this overflow if you have this side number stuff. If you use the first bit as a negative to represent negative number, then you need to think about it, because if you have overflow here, you will change a positive number to a negative number. 127 plus 1 should be 128. But because the range of this sign number, the maximum number is 127. So you got overflow. And this overflow will cause this number change it to a negative number. So this is not good, right? The same thing happens for underflow. So underflow means if you have something like, okay, I have a really, really small number, uh, negative 1 to 8, then I try to minus 1. So what happens? 128 actually equal to 1, 0, 0, 0, 0, 0, 0, 0. Okay, so if we do minus 1, it will become 1, 0, 0, 0, minus 1, 0, 0, 0, 0, 0, 0, 1. So it will become 0, 1, 1, 1, 1, 1, 1, 1, right? And this is actually a positive number, right? So you do a negative number minus 1, but you got a positive number. This also makes no sense. So you need to take care of the range of this sign number to avoid the overflow and underflow. This is something you need to pay attention when you work on these side numbers in binary.
Yo, I now I understand what's a negative number in binary. But I have a question. So far, we talked about the integer. It can be a negative number or positive number. How about the floating point? If we want to represent a number with some decimal point numbers, how can we represent in binary?
Okay, so this is really good questions. Let's look at the format for this floating point. So the idea is not so different. Of course, there's some different way to represent, but let's to take a look of this. So in the integer, we use the digit, the least significant digit to represent the 2 to 0, which is equal to 1, the last digits in a digit number, right? So actually, we can provide some digits like 2, negative 1, 2 to negative 2, and so on. So if you understand this part, then we can kind of use the bit to represent different stuff. So we kind of use maybe the first 10 bit to represent some like the integer numbers. Then use another 10 bit to represent the floating point. So in this case, the least significant bit is not 2, 0 anymore. It can be some like two negative numbers. So if you understand this part, we can use these to represent the floating point, right? So actually, there's another way to represent the floating point like this. We can try to consider to put some digit in the sequence number. Depends on like what's the how many byte or how many bit. Usually we use more than 1 byte to represent the floating point. In C languages, for integer we use 4 byte. For the double we use 8 byte. So we use uh, different range of digit to represent. But no matter how many bytes you want to use, how many bits you want to use to represent a number, this is another way you can try. The first digit is you use to is to represent a negative or positive, right? Just like what we covered before, negative or positive. Then we can have a range of this number. This number actually represent the exponential weight. So this number, for example, is number represent e. It can be, let's say, 0, 1, 0, 0. In this case, this number is equal to 2, 0, 1, 0, 0, which is 4. This will be equal to 2 to 4 times the flag. So in this case, you can use it to represent a really, really big number, even a really, really huge number, because you use exponential, this the way you use the exponential way. You can use like a few digits to represent big number. Then of course there's a fraction here. So for example, if the fraction is 1, 0, 0, 0, which is a, then it will be 2 to 4 times a, and so on. And of course, this explanation can be a negative one. So you can represent some like decimal numbers, decimal point numbers, right? So this is one way you can kind of to represent a bigger or a smaller or a more complicated real numbers in a limited restrict digit bit. So this is another way you can use, and this is a very small way to do. So it's a little bit different to what we have before. Before we use each bit to represent one precision. So it can be 2 power of 2 to 3, 2 to 5, 2 to negative 1. And for this one, it's not. We try to separate a sequence numbers to different bits. There's some bits they represent exponential. There's some bits they represent more like a real number. Then we use these numbers times this exponential to combine this number together to get then we can represent a like a really big complicated number in an easy way. This is for today. So I hope you enjoyed today's class. Today we talk about negative number in binary. We talk about floating point number in binary. The negative number point we recommend the two's complement methodology to compute the negative number. The reason is that in the two's complement this representation, we don't use two different binary number to represent one single decimal number zero. So this is definitely is a better way to use our limited restrictions in this like a bit and bytes. We only have this limited bit. How can we like store more data in this case? Okay, so for floating point numbers, we talk about a technique. It's like we chunk the bits a little bit. For the first couple bits, we use it to represent the exponential number, and for remaining part, is represent the real numbers. Then we combine these together to create a huge, a bigger, complicated number systems. And this is very important and useful technique in your future when you work on the systems. You will see this technique be applied in other different systems areas, and they are kind of common and very useful, right? Okay, so I hope you got these lectures right and hope you enjoy it. See you next time. The binary world is really interesting.